Hey, you guys, let's jump in. In today's lesson, we are going to talk about linear equations. Okay, all right. So, the first thing that we want to do is make sure that we understand what an equation is. So, an equation is a mathematical statement which contains the equality symbol, or what we like to call an equal sign. Okay. So a linear equation is a specific type of equation, and it's an equation that contains variables of degree 1 and can be written in the form ax plus b equals 0. Okay, so what we mean by when we say that it has a degree of 1, we mean that the highest exponent that we see in that equation will be a 1. Okay, so as you can look at these equations that I've put here, okay, 3x minus 7 equals 2, negative 5 times y minus 7 equals 2y plus 7, and t equals 2. All of these are examples of linear equations. I know that they're linear because the highest degree or exponent that I see is a 1. So if you take a look at this first equation where you have 3x minus 7 equals 2, we see that it has a variable. The variable in this equation is x, and its highest exponent is a 1. Now, even though I don't see a physical 1 here, anytime I have a variable that doesn't have a superscript, it is understood that its power or its exponent or its degree is 1. Okay? Now, if the degree was higher than that, it would be a different type of equation. So all of the equations that we look at in this section, all of their degrees will be 1. Okay? Now, as we dive a little deeper into equations, we will notice that there are going to be 3 types of equations that we will come across. Okay? The first type of equation that you're going to run into is called a conditional equation. Now, the properties of a conditional equation say that the equation is true for some value or values. Now, these are the equations we're most used to. These are the equations that if we've been given to solve, we list out their solutions. So as you can see in this example column, if I would have given you this original equation and I solve it for x, I would have gotten that x equals 19 over 5. This would be a conditional equation because this equation is only true when x equals this specific value. Okay, I can't plug in a 2 for this equation. I can't plug in 10. The only way this equation is true is for when x equals 19 over 5. So this equation is true under certain conditions. Okay, now anytime we've been given one of these equations, we usually list their solutions. Okay, just like we've done here, x equals 19 over 5. Now the next type of equation that you're going to run into is called an identity. Now, an identity is different from a conditional equation because it is true for all values or any values, okay? So if I would have given you this equation on the right-hand side and we were to solve it, you'll notice that I get the same answer on both the left-hand side and the right-hand side of the equation. So the way that I like to think about identities, I like to think about them like mirrors, okay? So hopefully when you look in the mirror, unless you're in some type of horror film, you see yourself. So in identity, you should see the same thing on both sides of the equation. This lets you know that it doesn't matter what you plug in for your variable, that equation will always be true. So the solution set for this type of equation is all real numbers, okay? Doesn't matter what you plug in, it's always going to work. Now, the last type of equations that we're going to run into are called contradictions, okay? So a contradiction is an equation that's not true for any value. So it doesn't matter what you plug into the equation, it's never going to be true. So in these example problem, you'll see here that on one side of the equation when we solved it, we got negative 24, and on the other side, we got negative 5. Negative 24 does not equal negative 5. That's not true. So it tells me that this particular equation has no solution, or you can say that the solution set is empty, okay? So another way to think about contradiction is that you get an equation that's false, okay? So those are the 3 types. You have conditional equations, identities, and contradictions. All right, let's move into some example problems. So the next thing we're going to want to know is that they may give us a point, and they may ask us, does this point, this ordered pair, represent a solution to this equation? Well, if it's a solution, that means that when we plug those values in for x and y into the equation, it should make our equation true. Okay, so you want to ask ourselves, does our point or our ordered pair make our equation true? Okay, so let's look at this first example. It says the linear equation 2x plus 4y equals 10 is given. Is the point -1, 3 a solution of the equation? All right, well, if it is a solution, that means that when we plug it into our equation, it needs to make it true. So in this ordered pair, your first coordinate is always your x value, and the second coordinate is always your y value. So that means everywhere in this equation where I see an x, I'm going to plug in -1, and everywhere that I see a y, I'm going to plug in 3. So I'm going to say 2 times -1 plus 4 times 3 equals 10. And I'm going to go ahead and solve this. So remember, anytime you're solving equations, keep your order of operations in check. So I'm going to go ahead and do 2 times -1, which is -2, plus 4 times 3, which is 12, equals 10. And then I'm going to combine like terms on the left-hand side. So -2 plus 12, that's 10. So then I look at my answer. Well, does 10 equal 10? It does. This is true. So because this is true, we can say yes. Okay. -1, 3 is a solution. Okay. Simple enough. All right, let's try the second one. Okay. Now, if you want to try it by yourself and then pause the video and then come back, that's fine too. All right, so let's look at number 2. It says the linear equation -5x plus y equals -3 is given. It wants to know, is the point -2, -5 a solution of the equation? So just like we did for number 1, we want to ask ourselves, okay, does our ordered pair make this equation true? So our first coordinate is going to be our x value. The second coordinate is going to be our y value. And we're going to plug those values into our equation and solve. So I have -5 times -2 plus -5 equals -3. I have -5 times -2, which is 10, minus 5 equals -3. I'm going to combine my numbers on the left-hand side. So 10 minus 5 is 5, equals -3. Now I'm going to look. In order for this to be true, I would need the same thing on the left-hand and right-hand side of the equation. So when I look at this one, 5 does not equal -3. That's false. So if they ask me, is -2, -5 a solution? This time, I have to say no. Okay? -2, -5 is not a solution. Cool.